Hello and welcome back to our channel. Today we are tackling stoichiometry questions from IB Chemistry SL Paper 1, and these questions will range from 2017 to 2022. This will be a great resource for exam preparation or if you're just refreshing your knowledge. So let's start with the first. So these questions came in November 2022. Let's jump into them. How many moles of carbon dioxide are produced in the complete combustion of 7 grams of ethene? Yeah. So first you have to write the combustion reaction. So C2H4 plus O2 gives you CO2 plus H2O. Now we need to balance it. In order to balance it, 2 here, 2 here. Yeah, and now to balance oxygen, we need to put a 3 here. Let's find the moles of C2H4 first. Moles of C2H4 would be given mass, which is 7 grams, and molar mass, which is 28. So this is 0.25. Now we have to find the moles of CO2. So I'll write the stoichiometric ratio between CO2 and C2H4 will be moles of CO2 by moles of C2H4, which would be equal to 2 by 1 because it's in the 2:1 ratio. So moles of CO2, moles of C2H4 we have found out as 0.25. This will be equal to 2. So finally I can say that moles of CO2 would be 2 times 0.25, that is 0.5. So finally option B is the correct answer to this question. Moving on to the next one. What is the change of state from gas to solid called? So whenever a gas gets converted to a solid, we generally call it deposition, right? So yeah, so answer should be option B. It's more or less like an informative question. The next one. How many oxygen atoms are present in 0.5 moles of barium, hydrated barium hydroxide? Yeah. So in 1 mole of BaOH whole twice dot 8H2O, we total have 10 moles of oxygen because 8 moles in H2O and 2 moles in BaOH whole twice moles of oxygen. Now we have 0.05 moles of barium hydroxide. In 0.05, we have 10 times 0.05 moles of oxygen atoms. So we have 0.5 moles of oxygen atom. Now we have to find the number of oxygen atoms. Therefore, number of oxygen atoms would be moles times the Avogadro number. So Avogadro number Na is given here. That is 6.02 times 10 to the power 23. If we simplify, we'll get 3.01 times 10 to the power 23, which is option A. So in our question 3, option A is the correct answer to this question. Now the next one. Which is a possible empirical formula for a substance with molecular mass 42. So our main idea behind solving this is we have to find the empirical formula masses of all the compounds and see like in which case molecular mass divided by empirical formula mass gives you a whole number. So here we'll neglect option C because C is not an empirical formula, so we don't need to check for it. For this one, empirical formula mass would be carbon is 12, hydrogen is 1, so 12 plus 1 will be 13. For CH2, empirical formula mass would be 12 plus 2, 12 for carbon and 2 for hydrogen, that is 14. We don't need to check for this. The last one will be C3H8, right? So it's 3 times 12 plus 8. So that is 44. 36 plus 8 is 44. Now, we have to find the molecular mass divided by the empirical formula mass. So for option A, MR by, just write it like this, by empirical formula mass. For option A, it will be 42 by 13. 42 by 13 will not be equal to, it will not be equal to a whole number. It will be 3 point something something. 3 decimal, there will be some number. So A is definitely not the answer. For option B, this ratio would be equal to 42 divided by 14. 42 divided by 14, we get the ratio as equal to 3. So B probably is the correct answer, but we'll also check D. D, we can clearly see it's 42 by 44. It will be 0 point some numbers here. So from all this, we can say option B is the correct answer to this question. Now we are done with November 22. Now we'll move on to May 22. So which equation represents the deposition of iodine? Deposition means, as we discussed in the previous section, is gas to solid. So from the options, only option B gives us gas to solid. So B is the correct answer here. Now which graph really represents the relationship between the amount of gas and the absolute temperature T with all the other variables in ideal gas equation held constant? We'll just write the equation PV equals nRT. So we need the relationship between N and T. Okay. So N equals PV by RT. And they have said that PV by R, and all these three are constant. PV are constant. R is already a constant. It's called the universal gas constant. So it's K by T. So this type of a graph, if I want to plot N versus T, what happens is if T is somewhere near to 0, your N will tend to infinity. So at T equals 0, N should be infinity. And that is only available in option B. So yeah, from this, we can say B is the correct answer to this question. Or this is also a standard curve. So a lot of you should be knowing how y equals k by x curve looks like, which is an asymptotic curve. Yeah. The next one. 30 grams of organic compound produces 44 grams of CO2 and 18 grams of H2 as the only combustion product. Which of the following is the empirical formula of the compound? So yeah, first you have to find the moles of CO2. Moles of CO2 is 44 divided by 44, that is 1. Now we'll assume that the entire amount of carbon in this organic compound has been burnt and all of the carbon has been transferred to CO2. So moles of CO2 should be equal to the moles of carbon in the organic compound. So yeah, moles of carbon would be equal to the moles of CO2. That is equal to 1. Now moles of H2O would be moles of H2O would be 18 divided by 18, that is 1. Okay. Now moles of hydrogen, as 1 mole of H2O contains 2 moles of hydrogen, so moles of hydrogen will be 2 times the moles of H2O, that is 2. Now mass of carbon plus mass of hydrogen, we have to check this. See, if the mass of carbon and mass of hydrogen, if I add them together, it comes out as 30, then there is no oxygen. But if this sum is not equal to 30, then there is some amount of oxygen present and we have to find the moles of oxygen. So mass of carbon would be 1 times 12, mass of hydrogen would be 2 times 1. Okay, this is 12, it will be 14 grams. So obviously 14 grams is less than 30 grams, so there is also oxygen. So mass of oxygen would be 30 minus 14, that is 16 grams. Just find the moles of oxygen too. Moles of oxygen will be 16. Molar mass of oxygen is also 16. Moles of oxygen is 1. Now we have to find the simplest whole number ratio between the moles of carbon, moles of hydrogen and moles of oxygen. So moles of carbon is to moles of hydrogen is to moles of oxygen. So this ratio would be 1 is to 2 is to 1, and you see the ratio is already in its simplest whole number. So from here we can say that the empirical formula would be CH2O. Carbon is 1, hydrogen is 2, oxygen is 1. So CH2O. From the options, we see that option D is the correct answer to this question. Yeah. The next one. Concentrations of chloride ion in a solution formed by mixing 200 centimeter cube of 1 mole per dm cube HCl and 200 centimeter cube of 5 mole per dm cube NaCl. You have to find the concentration of Cl minus ions. So first, moles of Cl minus from HCl solution. So you have so moles will be concentration times volume, but your volume should be in decimeter cube. So I'll convert the volume into decimeter cube. So moles of Cl minus from HCl will be 0.2 mole. Now we have to find the moles of Cl minus from NaCl. It will be again concentration times volume. Oh, sorry, yeah. Concentration is 5 and volume is 200. Again, convert the volume to decimeter cube. So 5 times 0.2, this will be equal to 1 mole, right? So we have to find the total moles of Cl minus. That is 1 plus 0.2, that is 1.2 mole. Okay. Total volume of Cl minus would be, how much volume? This 200 plus 200. 400 centimeter cube. We can convert it to decimeter cube, like we can divide it by 1000 and convert it to decimeter cube. Because we have to report the final answer in mole per dm cube, so it's 0.4 dm cube. Now concentration would be mole by volume, right? Mole is 1.2 and volume is 0.4. Unit will be mole per dm cube. So 1.2 by 0.4 will give me 3 mole per dm cube, and that's the final answer to this question. Now moving on to the next question. We have 8.8 grams of an oxide of nitrogen that contains 3.2 grams of oxygen, and we need to find the empirical formula of this compound. So let's find the moles of oxygen. So moles of oxygen would be, this is a given mass of oxygen and the molar mass of oxygen is 16, so this is 0.2. Then we have to find the mass of nitrogen. Now as it's an oxide of nitrogen, the compound will only contain nitrogen and oxygen. So to find the mass of nitrogen, we can deduct the mass of oxygen from the total mass of the compounds. That will give me the mass of nitrogen. That is basically 5.6 grams. So moles of nitrogen would be 5.6. Molar mass of nitrogen is 14. So if I simplify this, I'll get 0.4. Now we have the moles of oxygen, moles of nitrogen. So we have to find the simplest whole number ratio between moles of nitrogen and moles of oxygen. So that is 0.4 is to 0.2. If you simplify, you should get 2 is to 1. Divide both sides with 0.2. So 2 is to 1. So my empirical formula should be N2O, which is option B. And yeah, option B is the correct answer to this question. Moving on to the next one. What is the molecular formula of a compound with empirical formula CHO2 and relative molecular mass 90? So first, so basically we have to find N here. N is basically the molecular mass divided by the empirical formula mass. Molecular mass by empirical formula mass. 90. The mass of empirical formula CH2O is 12 plus 1 plus 2 times 16. Simplifying, it will be 90 plus 45, 90 divided by 45, which is 2. So N is 2. Therefore, the molecular formula is empirical formula whole N. This will be your molecular formula. So CH O2 whole 2, if I just open the bracket, I'll get C2H2O4. C2H2O4 is option B, and hence B is the correct answer to this question. Yeah. Moving on to the next question. Which sample contains the fewest moles of HCl? So in all cases, we have to basically find the moles of HCl. In the first one, moles is concentration times volume. So moles would be concentration. The volume should be in decimeter cube. So 10 divided by 1000 is 10 to the power minus 3. Or option A, you have 10 to the power minus 3. Option B, moles would be number of molecules divided by the Avogadro number, which is 6.02 times 10 to the power minus 10 to the power of 23. Sorry. So if I simplify this, I'll get 10. Right. In option C, we need to find the fewest moles, right? So we can eliminate B from here. Let's find C here. Yeah. So moles would be mass 0.365. HCl, hydrogen is 1, chlorine is 35.5. 36.5. So if you simplify this, you should get 10 to the power of minus 2. And the last one, moles would be, at STP, moles is given volume divided by the molar volume. Molar volume is 22.7. So if you simplify, you'll get 0.1. Out of these three, we see that the smallest value occurs at option A. So option A contains the fewest moles of HCl. Moving to the next question. We have 0.2 moles of sodium hydrogen carbonate, which is decomposed by heating until we have a constant mass. Yeah, we have to find how many moles of gas are produced. So we have to find the total moles of H2O and CO2 because both of them are gases. So let's find the moles of H2O. To write the stoichiometric ratio between H2O and HCO3. This ratio would be 1 by 2. So moles of H2O. Moles of NaCO3 is 0.2. So moles of H2O would be 0.2 by 2. So if you simplify, I'll get 0.1. Similarly, if you just find the moles of CO2, you'll get moles of CO2 by moles of NaCO3, which is the stoichiometric ratio. This will be equal to half. So moles of CO2 by 0.2, this will be equal to half. So we'll get the moles of CO2 as 0.1. The total moles of HCl, H2O and CO2 would be 0.1 plus 0.1, that is 0.2. So total moles of gas would be moles of CO2 plus moles of H2O. 0.1 plus 0.1, so value will be 0.2. So hence option B is the correct answer to this question. Yeah. Now we'll move on to November 21. There's the first question in which you have two containers. We have to find the total pressure after the valve is opened. So yeah, basically what happens is if I open the valve, the moles in container 1 and container 2, the total moles will remain constant. So we can conserve the moles. Let's say moles in container 1 is N1 and container 2 is N2. Okay. So we can write that N total will be N1 plus N2. So after I open the valve, total number of moles in the system would be equal to moles in container 1 plus the moles in container 2. So yeah. So NT is P total V total by RT. Okay. YT because the temperature is constant. N1 is P1 V1 by RT. And N2 is P2 V2 by RT. We see that RT can be cancelled out. PT VT. So VT would be the total volume, that is 4 plus 2. 6. Okay. P1. P1 in this case is 2 times 10 to the power 5 times 4. P2 would be 3 times 10 to the power 5 times 2. If I just simplify a bit, you'll get 6 PT would be equal to 8 times 10 to the power 5 plus 6 times 10 to the power 5. So yeah, PT would become will be 14 by 6. Yeah, times 10 to the power 5. 14 by 6, if you just like approximately divide this, you get 12, 2. So it will be approximately 2.33. So it is 2.33 times 10 to the power 5. That will be the total pressure. So from the options, you see that 2.33, we have here 2.3 times 10 to the power 5, and this will be the correct answer to this question. To the next one, we have to find the structural formula, empirical formula, and IHT. I mean, yeah, we have to find which combination is correct. So let's start. In the first case, structural formula is C6H12. So the empirical formula will be the simplest whole number ratio between these two. The CH2 should have been the empirical formula of A, but the empirical formula is C2H4, which is wrong. So A isn't the answer. The next one, C6H14. C6H14, if we take the simplest whole number ratio, 6:14, it will be 3:7. And hence the empirical formula is C3H7. So B can be the answer. Okay, can be. So option C, C8H8. And you have if you take the simplest whole number ratio, 8:8 is 1:1. So again, C can also be the answer. And in the last one, when you have C8H10, the simplest whole number ratio between 8 and 10 would be 4:5. Okay, so C4H5 should have been the empirical formula, but they wrote C4H6, so obviously this is incorrect. Now we have to find the answer between B and C. So there are two approaches here. The easier one, as we are discussing stoichiometry, the easier one would be to follow the formula. So alkanes have a general formula of CN H2n+2. Okay, and alkanes do not have any double bond, triple bond, or anywhere where like there is a deficiency of hydrogen. It has like the most amount of hydrogen possible in a organic compound. So yeah, so you have CnH2n. So if your N is 6, so it will be C6H14. Yeah, basically this C6H14 is an alkene, and as a result, in an alkene, as there are no double bond, triple bond, or ring, the ISD is equal to 0. So hence I can say option B is actually the correct answer to this question. Now moving on to the next one. Which statements describe a all homogeneous substance? Yeah, so this won't be the answer. Homogeneous mixture, we can separate the mixture if like there is a difference at boiling point, so this cannot also be it. Mixture needs a specific ratio of components to form. That's not true, because if you mix sugar and water, you can have different mixtures. I mean, yeah. And the last one, any sample has the same ratio. Yeah, it has the same ratio of components. That is correct. Yeah, option A would be the answer to this question. It's more like an informative one, but yeah, option A, we should go with option A. Yeah. The next one. What is the number of hydrogen atoms in 2 moles of CaHCO3 whole twice? So moles of hydrogen in 1 mole of CaHCO3 whole twice. As there are 2 hydrogens here, 2 atoms of hydrogen in 1 molecule of CaHCO3 whole twice. Total number of moles in 1 mole of CaHCO3 whole twice would be 2. So similarly, we can say moles of hydrogen in 2 moles of CaHCO3 whole twice would be 2 times 2, that is 4. So we have 4 moles of hydrogen. So number of atoms of hydrogen would be 4 times 6.02 times 10 to the power 23. So it will be 2.41 approximately times 10 to the power 24. So with that, I can say option D is the correct answer to this question. Yeah. Moving on to the next one. What is the sum of coefficient when the equation is balanced? This is from May 21. So we have to balance this equation. I'll just check if it's a yeah, it's not a redox reaction because it's +4 here and +4 here again. Yeah, we need normal balancing here. So let's start. Yeah, we can do twice NaOH, which will balance out the sodium, right? Now already 3 oxygens here. There are total 6 oxygens on the left. This is 1. So I can place a 3 here. I guess with this my equation is balanced. Nitrogen Na is 2, Sn is 1, oxygen is 6 on the left side, oxygen is 6 on the right side, hydrogen is 6 on the left side, 6 on the right side. Yeah. So option so if I just add up all the coefficients, it will be 1 plus 2 plus 1 plus 3, which becomes 7. So option D is the correct answer to this question. Moving on, which molecule has the same empirical formula as a molecular formula? So we have to write the molecular formula in each. So it will be C2H4O2. There's a molecular formula. Empirical formula EF would be the simplest whole number ratio of the coefficient. So it will be CH2O. So obviously E is not correct because the molecular formula and empirical formula are different. In the next one, your molecular formula is C2H6O. So the simplest whole number ratio between 1 is to 2, 1, 2 and 6 is basically the same. So here your empirical formula will also be equal to C2H6O. B can be an answer here. Molecular formula is C2H4. Empirical formula, which is the simplest whole number ratio between carbon and hydrogen, will be 1 is to 2. So CH2 would be the empirical formula. Similarly, for C4H10, the empirical formula will be the simplest whole number ratio between 4 and 10, which is 2 is to 5. So it will be C2H5. So checking all the options, option B is definitely the correct answer. What amount in mole of sodium chloride is required to make 250 centimeter cube of 0.1 mole solution? So first we'll find the moles of NaCl required. You need to find the moles. Moles is concentration times volume. So concentration, volume will be 250 by 10 divided by 1000 because I have to convert the centimeter cube to decimeter cube. Be 25 times 10 to the power minus 3 or 2.5 times 10 to the power minus 2, which is 0.025 mole. And also which is option B. Next one, you have 0.2 moles of magnesium mixed with 0.1 mole of HCl. Now we have to check which one is correct, which one is the limiting reagent, and what's the maximum yield. So find the limiting reagent, we have to find the N/SC ratio of the reactants. So we have to let's find the moles per stoichiometric coefficient for Mg. Moles of Mg is 0.2. Stoichiometric coefficient of Mg is 1. This is 0.2. Now we'll find the N/SC of HCl. For hydrogen, moles of HCl is 0.1. The stoichiometric coefficient of HCl is 0.05. The concept goes like this. The one with the lower value of N/SC is N/SC ratio will be your limiting reagent. Therefore, as N/SC of HCl is less than N/SC of Mg, Your HCl is the limiting reactant. Now we know the limiting reactant, so what happens is after we know the limiting reactant, we have to use it as a basis of our calculation. So I need to find the maximum yield of H2. So I have to find the moles of H2. I have to find the stoichiometric ratio between H2 and HCl. This ratio will be 1 by 2. So moles of H2. Moles of HCl is 0.1 as given in this question. This will be equal to half. So maximum moles of H2, that is the maximum yield, that will be 0.1 by 2, that is 0.05. So from there, limiting reactant is 0.05, maximum yield is, limiting reactant is HCl, maximum yield is 0.05. So it matches in option C, and hence option C is the correct answer to this question. Moving on, we have another balancing question. What is the coefficient of HCl when the equation is balanced using the smallest possible whole numbers? So it's interesting. Basically, if I put a 2 in front of HCl, that will balance out the chlorine, that will balance out the hydrogen. Oxygen and copper would already be balanced. So just putting a 2 in front of HCl would balance the entire reaction. Now we have to find the coefficient. Coefficient is directly 2, so option B should be the correct answer to this question. Now, what is the volume of oxygen required or needed when 5.8 grams of butane undergoes complete combustion? Okay, so let's find the moles of butane first. 5.8 divided by the molar mass of butane. Butane is C4H12, so 4 times 12 plus 10 times 1. This is approximately, in the option they have used the exact molar masses, but in my solution I have used the approximate molar masses. Both the cases will yield the same answer, no worries. Now we'll find the moles of oxygen. Moles of O2 by moles of butane. Butane is C4H10. This ratio will be 13 by 2. So moles of O2 will be 13 by 2 times the moles of C4H10. That will be 5 by 8 divided by 4 times 12 plus 10 times 1. Yeah, that is the moles. Now, if I want to convert moles to volume to volume at STP, what happens is we have to multiply the moles with the molar volume, which is 22.7. So yeah, volume of O2 would be moles of O2. This entire thing would be your moles of O2 times the molar volume. Molar volume is 22.7 dm cube. This entire thing would be in dm cube. Now if we check the options, 13 by 2, so this won't be correct. Okay, 2 and 13 on top, this won't be correct. This won't be correct because 22.7 divided by 1000. So this option, it matches exactly with our answer. 22.7, 13 by 2, and this is the moles of butane. So option B is, the correct answer to this question. What is the resulting concentration when 1 centimeter cube of 0.5 mole per dm cube nitric acid is diluted to 50 centimeter cube of water? Basically, you have to find the moles of HNO3 in the initial solution. That is concentration times volume, 1000. That is, if you simplify, it will be 5 times 10 to the power minus 4. Now, total volume after mixing 50 centimeter cube of water. Okay, total volume is 1 plus 50. That is 50 plus 1 centimeter cube. That is 51 centimeter cube. Yeah. Concentration would be moles of HNO3 divided by the volume. 51, we have to convert this decimeter cube to centimeter cube to decimeter cube. If you simplify, you'll get 5 times 10 to the power minus 1 by 51. Basically, it's 5 divided by 510. We have to simplify this. Now, if you simplify, approximately this will be 0.01, because 5 by 500 is 0.01. So yeah, 5 by 510, 5 divided by 510 will have a value which is very close to 0.01. So yeah, with this approximation, we can say option B is correct answer to this question. Next one, which contains the most atoms of oxygen? We can just find which one contains the most moles of oxygen, and that will be the answer. In this first case, moles of oxygen. Okay, moles of O2 would be 64 divided by how much? 16 times 2. That is 2, right? So moles of oxygen atoms would be 2 times the moles of O2, because each mole of O2 contains 2 atoms of oxygen. 2 times 2, that is 4. In the first case, it's 4. Next one, moles of O2 would be moles of O2 would be 1.2 times 10 to the power 24 divided by 6 times 10 to the power of 23. So if I simplify, it will be 0.2 times 10, that is 2. So again, the moles of O only, 2 times 2, that is equal to 4, right? In the next one, moles of C3H5O2, O3, sorry, 64 divided by 3 times 12 plus 5 times 3 times 5 plus 3 times 16. If I simplify, how much are we getting? 36. 16 times 3 is 30 plus 18, that's 48. 48 plus 30 is 78. 78 plus 6 is 84. 84 plus 5 is 89. So the moles of this thing will be 64 by 89. So from here, moles of oxygen would be 64 by 89 times 3. We'll work on this calculation later on. Let's check the last option. Yeah. So here you have 1.2 times 10 to the power 24 divided by 6 times 10 to the power 23. That is the moles of C3H5O3. If you simplify, you should get you should get 2. That's the moles of C3H5O3. The moles of oxygen would be 3 times the moles of C3H5O3, because one molecule of C3H5O3 contains 3 atoms of oxygen. So that is 6. So if you check the option, this one has the highest moles of oxygen. These two have 4. 64 times 3 is basically 192. So 192 divided by 89 would be approximately 2 point something. So yeah, so option C has the lowest value and option D has the highest value or highest moles of oxygen. So with this we can say D is the correct answer to this question. Now moving on to the next question. This is from November 20 paper. So the question says, which volume of ethane gas will produce 40 centimeter cube of carbon monoxide gas when mixed with 140 centimeter cube of oxygen? Yeah. Okay, so in this question, what we can do is we can just assume, we can directly use volumes in our stoichiometric ratio. First, let's check whether oxygen is the limiting reactant or ethane is the limiting reactant. We can do that by back calculation. Okay. So, I can write like this, volume of ethane divided by volume of CO2. This ratio will be 2 by 4, which is half. So volume of C2H6 by volume of CO2 is 40 centimeter cube. This is half. Volume of C2H6 will be 40 by 2. That is 20 centimeter cube. Okay. Now we can try finding the limiting reactant there are two approaches now. We can use the limiting reactant approach, or we can say how much ethane would be used if we are using 140 centimeter cube of oxygen gas. Let's try the second one, volume of C2H6 divided by volume of O2. This will be equal to 2 by 7. The volume of C2H6 by 140 is 2 by 7. C2H6 would be 2 by 7 times 140. So if I simplify, I'll get 40 centimeter cube of C2H6. Yeah. So the one with the lower value, so guess what? Actual volume of C2H6 present was 20 centimeter cube, but if all the oxygen reacted, then we would need 40 centimeter cube. Basically, C2H6 is the limiting reactant, and the amount of C2H6 in the solution would be 20 centimeter cube, which corresponds to option B. Next one. Which of these molecular formula are also the empirical formula? So here the ratio is 2:6:1, which cannot be simplified further. So in this one, your molecular formula will be equal to the empirical formula. Next one, 2:4:2. It can be simplified to 1:2:1. So the empirical formula will be CH2O. Basically, no, here the molecular formula and empirical formula are different. Okay. C5H12, 5:12. So this cannot be simplified more. This ratio is in the simplest form. So 1 and 3 would be the answer. So option B again. Yeah. What is the number of carbon atoms in 12 grams of ethanoic acid? So first find the moles of ethanoic acid. That is 12 divided by 60. That's 1 by 5. 1 by 5 is there's 0.2. Yeah. Moles of carbon would be, see, one molecule of CH3COH contains 2 atoms of carbon. So 0.2 moles of this ethanoic acid will contain 0.2 times 2. That is 0.4 moles of carbon. Now we have to find the number of atoms of carbon. That is moles times the Avogadro number, 6.02 times 10 to the power of 23. So 6 times 4 is 24, so it will be 2.4 times 10 to the power of 23. So that corresponds to option D. And yeah, in this one, option D is the correct answer. Next question, what is the molar mass of compound is 0.2 grams. So 2 moles of compound has a mass of 13 grams. So mass over molar mass, this will be equal to moles. Given mass is 13.2 grams. We need to find the molar mass. Number of moles is 0.2. So molar mass would be 13.2 divided by 0.2. 132 by 2, that is 66. So the molar mass is 66, which is option B. Oh no, 1 second. You have to check the option A and B. They have the same answer, but the significant figures are different. So we'll just quickly check once. So 0.200. So guess what? This one has 3 significant figures. This one has 3 significant figures. So I have to report the final answer in 3 significant figures. So that is 66.0. Option A would be the correct answer here. Now the next one, November 19, which contains the greatest number of moles of oxygen atoms. Again, find which one has the highest moles of oxygen atoms. That will be the answer. Basically here the moles of oxygen would be 0.05. And one molecule of MgNO3 hold twice contains 6 atoms of oxygen. So 0.05 moles will contain 0.05 times 3. So you have 0.3 moles of oxygen. Next one, moles of oxygen would be 0.05 times 4, because there are 4 oxygen atoms in one molecule. That is 0.2. Next one, moles of oxygen would be 0.1 times 1. That is 0.1. And the last one, moles of oxygen would be 0.1 times 2, that is 0.2. But from all these, we can see that option A is the correct answer to this question. Now the next one, which one is the correct answer? A mixture either homogeneous or heterogeneous and their chemical properties are an average of individual component properties. Not really. In a homogeneous mixture, the properties probably won't be average, depends upon the ratio. Mixtures are never heterogeneous and the chemical properties are an average of the individual components. That doesn't really matter. Mixture can be heterogeneous, so I can ignore this. Ignore this. Mixtures are either homogeneous or heterogeneous and their components retain their individual chemical properties. This is correct. Whichever mixture you have, the components will retain their individual characteristics. And the last one, mixtures are never homogeneous. This is also incorrect. Mixtures can be homogeneous or heterogeneous. There is no problem. Now we need to find the sum of the coefficients when the equation is balanced with whole numbers. So to balance it, we have the free element chlorine. We'll balance chlorine at the end. To balance oxygen, I have to put 2 in front of H2O. To balance hydrogen, I have to put 4 in front of Cl. 2 Cl is here. I can just put a 1 here, and this will, I guess, balance out the entire reaction. Manganese 1 and 1 on both sides. Hydrogen 4 on both sides. Oxygen 2 on the left side, 2 on the right side. Chlorine 4 on the left side, 4 on the right. So we have to find the sum of the coefficients. That is 1 plus 4 plus 1 plus 2 plus 1. That's equal to 9. So option D is the correct answer to this question. The next one, you have 0.1 mole of hydrochloric acid, which is mixed with 0.1 mole of calcium carbonate. We did a similar problem. And here again, we need to find the limiting reactant and the maximum yield. So guess what? For the limiting reactant, I would be using the moles per stoichiometric coefficient for HCl and CaCO3. HCl moles is 0.1. The stoichiometric coefficient is 2, that is 0.05. Similarly, for CaCO3, moles is 0.1. Stoichiometric coefficient is 1, so 0.1. So therefore, as N by SC of HCl is less than the N by SC of CaCO3, therefore HCl would be your limiting reactant. Done. So we know HCl is the limiting reactant. Now we have to find the maximum yield of CO2. So we'll use HCl as a basis of calculation. So moles of CO2 and write the stoichiometric coefficient. Yeah, moles of CO2 by moles of HCl. This will give me the ratio would be 1 by 2. 1 here, 2 here. That's why 1 by 2. So moles of CO2 would be, moles of HCl is 0.1. Therefore moles of CO2 would be 0.1 by 2, that is 0.05. So moles of CO2 produced would be 0.505, and HCl is the limiting reactant. From the options, clearly option C is the correct answer to this question. Moving on to the next question, this is from November 18. An antacid tablet containing 0.5 grams of NaHCO3, sodium bicarbonate, is dissolved in water to give a volume of 250 centimeter cube. What is the concentration of HCO3 minus in this solution? So basically, NaHCO3 would decompose into Na plus and HCO3 minus. Basically, and if you write the stoichiometric relationship between them, moles of HCO3 minus by moles of NaHCO3, this ratio would be 1 by 1 because the coefficients are 1 and 1 in both cases. So I can say moles of HCO3 minus would be equal to the moles of NaHCO3. Moles of NaHCO3 is how much? 0.5 divided by 84. Now, concentration of HCO3 minus science is basically moles of HCO3 minus divided by volume of solution in decimeter cube. Moles of HCO3 minus is 0.5 by 84, which we derive from this step. Volume of the solution is 250 centimeter cube, but we have to convert this 250 centimeter cube to decimeter cube. So we have to divide 250 with 1000. So to convert centimeter cube to decimeter cube, you divide it by 1000. It becomes 0.25. Finally, answer should be 0.5 by 84 times 0.25. 0.5, 84 divided by 84 times 0.25. That is option B. And B is the correct answer to this question. Now for this question, we have 16 grams of bromine, which reacts with 5.2 grams of metal M to form MBr2. We have to find the relative atomic mass of the metal M. So if I write the reaction, simply it can be written like this. I'm not writing the states. Yeah, this is the reaction. So first find the moles of Br2. Moles of Br2 is mass of Br2 divided by the molar mass. So bromine is 80, so Br2 would be 80 times 2. 16 by 160, that is 0.1. That's the moles of Br2. Now to apply the stoichiometric ratio between M and Br2 to find the moles of M. So moles of M by moles of Br2. This would be 1:1, so 1 by 1 or basically equal to 1. So moles of M divided by 0.1 equals 1. So from here we can write that moles of M equals 0.1. Now we know that mass of M by atomic mass of M, this will give me the moles of M Now mass of M is given by given as 5.2. Atomic mass of M we need to find, and moles of M we found here, that is 0.1. Therefore atomic mass of M would be AT mass of M, or atomic mass of M. This will be equal to 5.2 by 0.1. Simplified will be 52. So from this we can say option C is the correct answer to this question. The next one, how many moles of FeS2 are required to produce 32 grams of SO2? Let's find the moles of SO2 first. That is mass divided by the molar mass of SO2. Molar mass is 32 times 1 plus 2 times 16, that is 32 divided by 64. That is basically 0.5. This is the moles of SO2. Now we know the moles of SO2, we have to use stoichiometric ratio to find the moles of FeS2 and we'll be done. Moles of FeS2 divided by moles of SO2. This will be equal to 8 by 4. No, 4 over 8. FeS2 is 4, so 4, and SO2 is at the denominator, so I'll put 8 here. 4 by 8 would be 0.5. So moles of FeS2, and moles of SO2 is 0.5. We have already found out in the previous step. Moles of FeS2 would be 0.5 times 0.5, that is 0.25. So you can say option A is the correct answer to this question. Now to the next question, what is the formula of magnesium nitride? Nitride is N3 minus ion. Okay, so we have Mg2 plus and N3 minus. So what we can do is we can take 2 N3 minus and make it like total of 6 minus charge, and we can take 3 Mg and make it 6 plus charge. If I combine both of them, your net charge will be 0. After this combination, my molecule will be Mg3N2, which is option D. And option D is the formula of magnesium nitride. Then there is the nitride ion. Next one, we have to find a percentage yield. What is the percentage yield when 2 grams of ethene is formed from 5 grams of ethanol? So this is a little complicated reaction, but it's okay. Ethanol. So C2H5OH. This becomes C2H4, which is ethene, plus H2O. This is the reaction. This is also called a dehydration reaction or beta elimination reaction. So first, moles of ethanol, or C2H5OH, would be 5 divided by the molar mass, that is 2 times 12, 5. There's total of 6 hydrogen here in this molecule. So plus 6 times 1 plus 1 times 16. If I simplify, it will be 5 divided by 24 plus 6 plus 16. That is 5 divided by 46. That is the moles of ethanol. Now we have to find the moles of ethene. Moles of ethene we can find by the stoichiometric ratio between ethene and ethanol. So ethene and ethanol both are in 1:1 ratio, so this will be equal to 1:1 or 1. Basically, moles of ethene would be equal to the moles of ethanol. C2H4 ethene would be equal to the moles of ethanol, which is 5 by 46. Moles of ethene, right? Now we have to find the mass of ethene. That is moles times the molar mass. Molar mass of ethene is, sorry, this is 46. Molar mass of ethene is 2 times 12 plus 4, 28. So 5 times 28 by 46, this is the mass of ethene. Now percentage yield would be actual mass divided by theoretical mass times 100. See, by calculation we found that this much ethene should have been produced, but in reality only 2 grams is produced. So that is, this will be actual mass by theoretical mass times 100. So in this case, your actual mass would be 2, because that's the mass that has been formed, and the calculated mass will be this 5 times 28 divided by 46. So 46, you can take it in the top and multiply it with 100. So the answer would be 2 times 46 times 100 divided by 5 times 28. What? If I check the answers properly, 5 times 28, 5 times 28 should be at the denominator. Yeah, if you check closely, this option actually resembles our answer. If I simplify 2 by 28, 5 by 46 would be 46 by 5 times 100. Because the fraction at the denominator, we can move it to the numerator by flipping the fraction. So this exactly corresponds to our answer, and hence option B is the correct answer to this question. Yeah. So in this question, we have to find the volume of the final solution if 100 centimeter cube of a solution is diluted to a concentration of 0.2 mole per dm cube. First, you have to find the moles of moles of 1.42 grams of sodium sulfate, moles of Na2SO4. This is basically your given mass with the molar mass, which is 142, that is 0.01. That is the moles of Na2SO4. Now, Now, this much moles will be present in this solution which has a final concentration of 0.02. What I can do is I can do moles divided by volume, that is 0.02, and find the volume of the final solution. So 0.01 by 0.02, this will be equal to the volume of final solution. So if you simplify, so it will be 0.5 dm cube, which is the volume of final solution. And as I need the answer in centimeter cube, I have to multiply it with 1000. That is 500 centimeter cube. So option C is the correct answer to this question. So in this question, we have to find the number of oxygen atoms in 2 moles of hydrated sodium carbonate. So number of moles of oxygen in 1 mole Na2CO3 dot 10 H2O. This will be equal to the number of oxygen atoms in 1 molecule of Na2CO3 dot 10 H2O. So how many atoms of oxygen are there in 1 molecule of this? So you have 10 oxygen in the 10 H2O part and 3 oxygen here. So total you have 13 oxygen atoms. So 13 oxygen atoms in 1 molecule. And so similarly you can say in 1 mole of Na2CO3 dot 10 H2O, I have 13 moles of oxygen atoms. Now number of moles of oxygen in 2 mole of Na2CO3 dot 10 H2O. If you have 2 moles, that will be 13 times 2, that is 26. So you have 26 moles of oxygen. Therefore, number of oxygen atoms would be moles times the Avogadro number, that is 6.02 times 10 to the power of 23. So 26 times 6.02 would be approximately 160. So you'll simplify and say 1.6 times 10 to the power 25 approximately, which corresponds to option D. Yeah. Now we have to balance this and then find the sum of coefficients, which is overall simple. So I'll just balance sodium first. Sodium, this will be 2 here, oxygen and hydrogen. There are 2 hydrogen atoms on the right, so I can put it 2 here. That will also balance out the chlorine. And for oxygen, I have like 3 oxygen there, 2 is here. Just put a 1 here, that will balance out the oxygen. Now for sulfur, 1 and 1. I guess that will evenly balance out the reaction. So sodium, 2 sodium on the left, 2 sodium on the right, done. Sulfur, 2 on the left, 2 on the right. Oxygen, 3 on the left, 3 on the right. Hydrogen, 2 on the left, 2 on the right. And chlorine, 2 on the left and 2 on the right. Yeah. So 1 plus 2 plus 1 plus 1 plus 2 plus 1. So it will be 1, 2, 3, 4, 5, 6, 7, 8. Answer should be 8, which is option C. What is the formula of ammonium phosphate? Ammonium is NH4 plus, phosphate is PO4 3 minus. Combining these 3 can only be possible if you have NH4 whole thrice PO4, which corresponds to option B. Now in this question, we have to find the percentage yield when 7 grams of ethene produces 6 grams of ethanol. So yeah, first we'll see how much moles of ethanol is formed from 7 grams of ethene. So moles of ethene would be, or C2H4, mass of ethene divided by molar mass of ethene. So that's the moles of C2H4. Now, you have to find the moles of ethanol formed. In order to do that, you have to write the stoichiometric ratio between ethene and ethanol. So, I write moles of ethanol, that is C2H5OH, divided by moles of C2H4. This ratio will be 1 by 1 because the coefficients in this balanced reaction is 1 and 1. Now, so if I just simplify it a bit, we'll find that moles of C2H5OH divided by 7 by 28, this should be equal to 1. 7 by 28 is the moles of C2H4. So moles of C2H5OH, this will be equal to 7 by 28. Now we can multiply it with the molar mass of ethanol to find the mass of mass of ethanol produced. That is moles times the molar mass, which is 48. Now we have to find the percentage yield. Percentage yield is experimental mass divided by theoretical mass times 100. Experimental mass is the actual mass of ethanol that will be produced from reaction, right? So experimental mass divided by theoretical mass times 100. So experimental mass is the mass that has been obtained in the experiment. So experimental mass is 6 grams of ethanol. So yeah, it will be 6 divided by theoretical mass is the mass of the ethanol which we obtained from our calculation. So that is 7 by 28 times 46, and we have to multiply it with 100. Now I can move the 28 to the numerator, so it will be 6 times 28 times 100 divided by 7 times 46. If I finish the calculations properly, I would see that option 7 by 46. Yeah, option D is the correct answer to this question. Now moving on to the next question. We have to which graph shows the relationship between volume and pressure of a fixed mass of ideal gas. So fixed mass means Yeah, they haven't told us anything about the temperature, but we will assume that the temperature is also constant. Right? If the temperature is constant, the equation will be PV equals nRT, and this nRT, this entire thing will be a constant K. So P equals K by V. This will be the relation. Now if I want to plot it, it will become Y equals K by X. Now see, when volume becomes 0, your pressure becomes infinity. So if you tend volume to 0, your pressure would tend to infinity. So that happens only in option A. So we can say that option A is the correct answer to this question because it satisfies the initial condition. Other than that, y equals K by X is, like most of you should be known with this type of curve, and it looks like this, which X and Y axis has the asymptotes. Now for this question, you have to find the molecular formula when the mass of percent mass of carbon and the molar mass is given. So we'll assume that total mass of the hydrocarbon is 100 grams. Out of it, mass of carbon would be equal to 84.6 grams, and mass of hydrogen, would be 100 minus 84.6. As it's given, it's a hydrocarbon, so it consists of only carbon and hydrogen. So this will be 100 minus 84.6 is 15.4 grams. Moles of carbon would be 84.6 divided by 12, so which on simplification gives me 7.05, and moles of hydrogen would be 15.4 divided by 1, which is 15.4. Now we have to find the simplest whole number ratio between the mass of carbon and moles of carbon and moles of hydrogen. So moles of carbon is to moles of hydrogen. 7.05 is to 15.4. Now we know that 15.4 is divisible by 7. So 7 times 22 approximately gives you 15.04. But we have 7.05 on this side. So I'll approximate 7.05 as 7. It will be 7 is to 15.4. Now if I divide both sides with 7, I'll get 1 is to 2.2. Okay. Now multiply both sides with 10. It will be 10 is to 22. And then divide both sides with 2. That is 5 is to 11. So from here, I can say that C5H11 is the empirical formula. Now let's check, let's find the molecular formula. So this is the empirical formula, right? So to find the molecular formula, we have to find N, which is molecular mass divided by empirical formula mass. Molecular mass is 142.3, empirical formula mass is 5 times 12 plus 11. So that is 142.3 divided by 6071. So N is approximately equal to 2. Right, so the molecular formula will be C5H11 whole N. So that will be C5H11 whole twice. So that is C10H22. C10H22, and we see option C is the correct answer to this question. Yeah. Moving on to the next one, we have to find out which one is a homogeneous mixture. Homogeneous mixture means which cannot be separated easily. Oil and water are not homogeneous, they're heterogeneous, because oil forms a layer over water. Sand and water obviously will never mix. Ethanol and water will form a homogeneous mixture, and chalk and sand will form a heterogeneous mixture. So from this, option C is the correct answer to this question. Now moving on to November 17, we have to find the sum of coefficients when the following equation is balanced using smallest whole numbers. We have to balance this equation. How could we do that? Yeah. C2H5OH and CO2. We can do, let's just randomly start. We can put a 2 in front of this to balance out the hydrogen, right? So after putting a 2, you have 12 hydrogen on the left and 12 hydrogen on the right. Now we have to check for oxygen and carbon. So see, carbon is 6 on this side and carbon is till now 2 to the 4, 5 on this side. So if I multiply CO2 with 2, then what happens is the number of carbon atoms on both sides will become 6. Okay, so this is done. Now we have to check for oxygen. Oxygen we have 6 on this side. Oxygen we have 2 plus 4, that is 6 on this side. So if I put a 1 in front of this, the entire reaction gets balanced. Now the sum of coefficients, 1 plus 2 plus 2, that is equal to 5. So option B will be the correct answer to this question. Moving to the next one. How many grams of sodium azide are needed to produce 68.1 dm cube of N2 at STP? So we are given the volume of N2 at STP, so we can find the moles of N2. Moles of N2 will be volume at STP divided by molar volume, which is 22.7. Now 22.7 times 3 is 68.1. Yeah. So on simplification, this gives me moles of N2 equals to 3. Now we have to find the moles of sodium azide NaN3. So I can write the stoichiometric ratio between N2 and NaN3. NaN3 by moles of N2. The stoichiometric ratio would be 2 over 3, because the coefficient of NaN3 is 2 and for N2 is 3. It will be 2 over 3. So I can say moles of NaN3, moles of N2 is 3. This is equal to 2 by 3, sorry. So moles of NaN3 would be 2 by 3 times 3, that is equal to 2. So we have 2 moles of NaN3 that will be formed. Now we have to find the mass of NaN3. That is moles times the molar mass of NaN3. Molar mass of NaN3 is 65 given. 65 times 2 is 130. 130 or 130.0. No worries here. And our option C would be the correct answer to this question. Yeah. Now moving to the next question. So here this is a problem of order of crystallization. We have to find X here. Most of the information is given. So 32.2 grams of Na2SO4.XH2 is heated, leaving 14.2 grams of anhydrous Na2SO4. We have to find like the value of X. Okay, so there are two approaches here. One is we can do a moles approach. Another one is we can conserve the mass. Like we can say that the mass of reactants is equal to the mass of products. So we know that 14.2 grams is the mass of Na2SO4 and the mass of H2O would be 32.2 minus 14.2. Yeah, because total mass of reactants is equal to the total mass of products. So if we do that, we'll get 18 grams of H2O. Now we know the mass of Na2SO4, we know the mass of H2O. Okay, we can find the moles, and again from the stoichiometric ratio, we can find X. Let's try that. We can find that the moles of Na2SO4, it would be 14.2 divided by 142. Okay, that is 0.1. Moles of H2O would be 18 divided by the molar mass 18, that is 1. Now, I write the stoichiometric ratio between H2O and Na2SO4. Na2SO4. The stoichiometric ratio would be equal to X over 1 because coefficient of H2O is X and Na2SO4 is 1. So moles of H2O is how much? Moles of H2O is 1. Moles of Na2SO4 is 0.1. This will be equal to X. If I simplify, X becomes equal to 10. So from this we can say D is the correct answer to this question. Now the next one. How many atoms of hydrogen are there in 0.5 moles of NH4 whole twice CO3? So I can start by this. We can say that moles of nitrogen or moles of nitrogen atoms present in 1 mole of NH4 whole twice CO3, this will be equal to 2. How? Because in 1 molecule of NH4 whole twice CO3, I have 2 atoms of nitrogen. So in 1 mole of this compound, I'll have 2 moles of nitrogen atoms. Now we have to find the moles of nitrogen in 0.5 moles of this compound. So moles of nitrogen atoms present in 0.5 mole of NH4 whole twice CO3. This will be equal to 2 times 0.5. Okay, and that becomes 1. So it's total 1 mole of nitrogen atom. Therefore, we can find the number of nitrogen atoms. This would be moles times the Avogadro number. Moles is equal to 1. Avogadro number is 6.02 times 10 to the power of 23, which gives me a final answer of this only. So we can say option D is the correct answer to this question. Moving on to the next one. This is from May 2017. Which factors affect the molar volume of an ideal gas? So molar volume, right? Molar volume means just check volume is nRT by P. Yeah, we have to check which factors will affect the molar volume, right? So moles and R, these two will be constant for a fixed amount of gas. So only temperature and pressure can change the volume. So 1 and 2. So option A will be the correct answer to this question. The next one. What is the maximum volume in dm cube of CO2 when produced when 1 grams of CaCO3 reacts with 20 centimeter cube of 2 mole per dm cube HCl? Okay, alright. So first we have to find the limiting reactant. We have to find how much moles of CO2 will be produced. As it's at STP, we can multiply the moles of CO2 with the molar volume to get the final volume. So first let's find the moles of CaCO3. This will be 1 by 100 mass over molar mass. Moles of HCl would be concentration times volume in decimeter cube. Okay, now we have to find the limiting reactant. So we have to find moles per stoichiometric coefficient of CaCO3. So moles is 1 by 100, stoichiometric coefficient is 1. So 1 by 100 would be your N by SC of CaCO3. Similarly, N by SC for HCl would be 40 over 1000 or 4. If you just simplify this, 40 over 1000 and also you have to divide it by 2. So yeah, if I simplify it a little bit, I'll get 2 by 100. So definitely between 1 by 100 and 2 by 100, 1 by 100 is smaller. So N by SC of CaCO3, this is smaller than N by SC of HCl. Therefore, CaCO3 is the limiting reactant. Now we know the limiting reactant. We'll use it as a basis of our calculations. So I have to write the stoichiometric ratio between CaCO3 and CO2. And write moles of CO2 by moles of CaCO3. This will be equal to 1 by 1. So what I can say that moles of CO2 is equal to the moles of CaCO3. So moles of CO2 equals moles of CaCO3. Moles of CaCO3 is 1 by 100. Okay, now that is the moles of CO2. Now we have to find the volume of CO2. Volume of CO2 would be moles of CO2 times the molar volume. Molar volume is 22.7. So yeah, this will be the answer. This will be the final answer. This is the amount of CO2 produced in decimeter cube. From the options, we clearly see it's option C. So yeah, option C is the correct answer to this question. The next one, how many moles of oxygen atoms are there in 0.5 moles of hydrated iron 2 sulfate? So this is the formula. So in one molecule of this compound, we have, now let's check how many atoms are present, how many atoms of oxygen are present. So we have 6 atoms here. 4 times 2 is 8, 6 plus 2, 6 plus 8, we have total of 14 oxygen atoms in one molecule of this compound. Right. Now we can say that moles of oxygen atom in 1 mole of this compound would be this will be equal to 14, right? Now we have to find the number of moles of oxygen in 0.5 moles. So we have to multiply 14 with 0.5. 5 mole of this compound. That is 14 times 0.5 is 7. So we have total of 7 moles of oxygen. And we need to find the moles of oxygen atoms only. So from that we can say option B is the correct answer to this question. Now again, a balancing question, we have to find the sum of coefficients. This is obviously an incomplete combustion, so put a 8 in front of carbon monoxide, 9 in front of H2O. Carbon and hydrogen are balanced. Now 8 plus 9, we total have 17 oxygen on the left, so it will be 17 by 2. Now yeah, I can put 17 by 2 in order to balance the oxygen. And this will be 1. Now I can multiply all the sides with 2 to make everything as whole numbers. So twice CH18 plus 17O2. This will give me 16CO plus 18H2O. Now I have to add up the coefficients. 2 plus 17 plus 16 plus 18. So 2 and 18 is 20. This will be 33. 20 plus 33 gives me 53. So I can say C is the correct answer to this question. Moving on. What is the density of a sample with a volume? This is very simple. Density is mass over volume. We have to take care of the significant figures, obviously. So 34.79 divided by 12.5. This problem is actually from your last chapter. Probably by mistake I put it here. But yeah, 34.79 divided by 12.5. So I can remove the decimals now. Now we see that there are like it's a division between two numbers, one with 4 significant figures, other one with 3 significant figures. So my final answer will be in 3 significant figures. Yeah. So let's do this division, but just up to 1 second. So it'll be 3479 divided by 1250. Yeah, we'll solve this division, but up to only 3 places of decimal. So 1250 times 2 is 2500, right? So that is so it will be 979. Yeah, no decimal. Now 1250 times 8 gives me 1250 times 8 is 8,000 and 2,000, 10,000 exactly. So we have to like put 1250 times 7. 1250 times 7 is 8750. So it will become 1040. Now I would require one more number. So now we don't need to perform the calculations after this, because see the answers are these two. One has 4 significant figures, another one has 3 significant figures, right? Or we could actually we don't even need the second place of decimal. We can the first place is 2, so obviously the answer will be in between C and D. C has 4 places, D has 3 places, and I just told you that the solution of density should be reported to 3 places of decimal, because 12.5 has the lowest number of decimals or significant figures, that is 3. Yeah. From there I can say D will be the correct answer to this question. Now we have to find the expression of volume of hydrogen gas produced at STP when 0.3 grams of magnesium reacts with HCl solution. Okay, so there's excess HCl. So first find the moles of magnesium. Moles of magnesium would be 0.3. Molar mass of magnesium is approximately 24, or from the options I can predict that is 24.31 moles. Now we have to find the moles of H2. So I have to write the stoichiometric ratio between H2 and Mg. So moles of H2 by moles of Mg. This is 1 by 1, because here you see it's 1, here you see it's 1 again. So moles of H2 this should be equal to moles of Mg. That is 0.3 by 24.31. Now we have to find the volume of hydrogen gas. Volume is moles times the molar volume. So at STP, this would be moles of hydrogen gas, this is the moles, times the molar volume. Molar volume is 22.7. So from this we can say option B is the correct answer to this question. Moving on, we have 5 centimeter cube of 2 mole per dm cube sodium carbonate solution, which is added to a volumetric flask. Volume is made up to 500 centimeter cube of water. What is the concentration? So let's just find how much moles of sodium carbonate was initially present, and then we have to just divide it with the volume of 500 centimeter cube or 0.5 dm cube to get the final concentration. So moles of Na2CO3 added. This will be from here. Concentration times volume. Concentration is 2, volume is 5 divided by 1000. We have to convert the centimeter cube to decimeter cube. It will be 10 by 1000. On simplification is 0.01. That's the moles of Na2CO3 added. Now concentration of Na2CO3 would be moles divided by the volume. Volume is 500 centimeter cube. That will be 0.5 dm cube. Now if I just simplify a little bit, we'll find it's 1 by 50. 1 by 50 is 0.02. So that is the concentration, or option C is the correct answer to this question. Now, which statement about mixtures is true? The components can be elements or compounds. All components must be in the same phase. The components retain the individual properties. So components will obviously retain their individual properties in a mixture because they are not losing their chemical properties. So 3 is definitely correct. Components may be elements or compounds. This is also correct. Your component may be in elemental form or in compound form. There is no problem. The problem is with 2. I mean, it's not true that all components must be in the same phase. Okay, it's a mixture. It can be a homogeneous or heterogeneous mixture. It's not specified exactly in the question. So yeah, so we can say option 1 and 3 are the only solutions. So I would go with option B. Now the last question of our discussion: which compound has the greatest percentage by mass of nitrogen atoms? So a little tricky here, but it's fine. For NH3, it's 14. This is the mass of nitrogen divided by the molar mass of this compound, that is 17 times 100. Okay. N2H4 will have 2 times 14 by 2 times 14 plus 4 times 100. This will be 28 by 32 times 100. Okay, so if I simplify, it will be 14 by 16 times 100. Now 14 by 16 times 100 is greater than 14 divided by 17 times 100. So I'll eliminate option B. Option B can't be the answer. Let's check option C. So mass will be 2 times 14. Molar mass of this compound will be 2 times 14 plus 4 times 16 times 100. So it's 28 divided by 28 plus 40 and 24, that is 64 times 100. So 28 divided by 8492 times 100. Now if I look into the answer, we see that 14 by 16 is a lot greater than 50%, while 28 by 92, this is less than 50%. For 50% we need for like 46 over 92. So obviously C is smaller than A, so I'll also eliminate C. Last one, NaNO3. NaNO3 mass of nitrogen is 14, sodium is 23, plus 14 plus 3 times 16 times 100. Divided by, how much will this be? 16 times 3 is 48, 48 plus 14 is 62, 62, 65, 85. So it will be 14 divided by 85 times 100. Again, it will be a lot smaller than 14 over 16. So I can also eliminate out option D, and I can finally say option A will be the correct answer to this question. With this, we come to an end to our discussion. I'll soon be posting more videos about on the other chapters. Till then, stay tuned, and thank you so much.